So we're going to make a video. It's been a while since I've made one, but this video is going to be about what does it mean to solve an equation and what does that look like visually, because I want to make sure you guys understand the misconceptions that come up a lot when solving quadratics, and I couldn't find a video out there that showed you what I wanted to show you. So let's look at something like this. So if I have 3x squared equals 12, well, there's what we would call a term that's quadratic, meaning it has a second power on it, and we can get to that no problem. We undo the multiplier of 3, and then we say what number times itself is 4? Well, it's either 2 or negative 2, because both of those answers work. But what I want to show you guys is something like this. So if we go to Desmos, and I'm going to show you guys a couple of different options. So this right here is the graph of 3x squared, and this right here is the graph of y equals 12. And so if you take a step back and think about the equation we were looking at as the second step to a system of equations, then you can see that when x equals negative 2 or x equals positive 2, we get 12, which is what we were hoping to see given this information right here. If x is 2 or negative 2, the output is 12. Okay, so that's one way of thinking about it. The other way of thinking about it is, what if instead of thinking about the equation we were looking at, what if instead of looking at this, we looked at 3x squared minus 12 equals 0. Okay, so this equation can be factored by taking a 3 out and getting x squared minus 4 equal to 0. And then maybe you'll recognize this, maybe you won't at this point. This is a difference of perfect squares. So this is x plus 2 and x minus 2. So if we have that equation, we can see where this is going to work. We can say 3 times some number is 0. Well, I know that if I have one thing times another thing, and the answer is 0, then either one or the other or both of these numbers have to be equal to 0, just like here. If I have 3 numbers multiplied together, the answer is 0, then either this is 0 or this is 0. Okay, so here what that looks like, is here's that function we were looking at, and look, we get the same thing. If we plug in x is negative 2, we get out 0. If we plug in x is positive 2, we get out 0. Okay, that's one example. What if we look at something like this? 3 times some number times itself is 12. Well, this one is doable. Let's see where we could go. We can divide the 3 out, and then some number plus 2 times itself is 4. So the question is, can I answer this question? Do I know, is there some number that times itself is 4? Yes, we can answer that question. We can say that the number that times itself that's 4, x plus 2, is either equal to 2 or x plus 2 is equal to negative 2. So we can get from this section x is 0, or from this section x is negative 4. can see that. There you go. So let's look at it again graphically. So if we had this function right here, and we said, where does this equal 12? Well, it equals 12 here at -4, and it equals 12 here at 0. But I can also say, if I have this quadratic, which would be 3x, 3 times the quantity x plus 2 squared minus 12 equals 0 instead, well, where did those intersect? Well, look. Oops, that's not the one we want. We want to get rid of that one. No, go away. Well, try to ignore that one. We want this one and that one. So then again, we still have the 4 and the -4, or the -4 and the -4, and the 0 and the 0. So the x's still line up, even though we've changed what questions we're working on, but the equations are still the same. Okay. I'm going to pause there and go to part 2.